This video is going to walk you through the dividing decimals assignment. So let's go ahead and get started. I just want to reinforce that anytime you are given a horizontally written division problem like this, you can actually go through and you can rewrite it in two different ways. It can be represented as 17 divided by 4, which if we're trying to solve this longhand, it doesn't serve a purpose, but I do want to start reinforcing that our fractions unit is coming up, but I also want to keep in mind that this is a division symbol now. They're kind of interchangeable. For this purpose, we are going to do 17 as our dividend because it's in our box, and then 4 is our divisor. So the divisor is at the door. And then I always remember the first thing that you see always goes under your bed. Just like if you're cleaning your room, the first thing that you see in your room, you tend to just shove underneath your bed. So that's kind of like your overall cleaning concept. So that's what I've got. Anywho, so now I have to go through, and if you remember, we're using our overall concept of we're going to multiply, then subtract, bring one down, and then repeat, okay? So I'm going to start off with 4. Can I multiply anything by 4 to get 1? And I cannot. I could do 0 if I wanted to, but I don't need a place value holder there. So I'm just going to scooch these on over, and instead of trying to go into 1, I'm going to try to go into 17. So instead I'm asking myself, what can I multiply by 4 to get close to 17 without going over? And I know if I take 4 times 4, I will get 16. So that's the whole process of multiplying, right? I just multiplied. Now I'm ready to subtract, right? So 17 minus 16 will get me 1 left over, right? And then I have a bring down, right? Well, wait a second. I have a remainder. Remainders are not allowed this year. Remainders are like curse words now, okay? We do not say remainder anymore in 6th grade. So instead, we want to be able to keep going, and I need to be able to bring down. I just subtracted, and I need to be able to bring down. So instead of just putting R1 like we used to when we were little, we're going to add a decimal point and a 0. And the reason why we can do this is because it will allow us to follow our step of bringing one down, right? And it will also allow us to not change the overall value. So this is still worth 17, right? I could add a bazillion zeros after this, and it is still worth 17. The value has not changed. So I have my decimal point. My 0 can now be brought down. And as soon as I add my decimal, I'm going to raise it to the roof. I'm going to put it right here so it stays in the column to organize my place values up here, my answer or my quotient. Okay, so now that I brought it down, I'm going to repeat, right? So I'm going to go back over this and say, okay, now I'm asking what times 4 gets me close to 10 without going over, right? And I'm going to take 4 times 2, correct? 4 times 2 will get me the product of 8, right? So I just multiplied, cha-ching, check, check, right? And now I'm ready to subtract. So if I subtract, I'm left with 2, correct? And after I'm subtracting, I'm ready to bring down, correct? So again, I don't have anything to bring down, but I have a remainder, so I have to keep going, okay? So I'm going to add a 0 because it doesn't change the value, right? This is still worth 17, okay? I can add a bunch of zeros. It doesn't change. But it allows me to bring one down, which was my next step, right? So when I bring that down, I'm allowed to go through and repeat the process again because now I can ask myself what times 4 gets me close to 20 without going over. And I know that 4 times 5 will get me 20, right? So I will be able to subtract 20 from it, and I finally have no remainder. I ran out of room, so that's my little 0 to show no remainder. Okay, so that was me showing you how to divide without putting in a R for remainder. Okay, instead we are actually turning our remainder into a real number equivalent, which is 4 and 25 hundredths. Okay. So here we go. We're going to move on to our next problem. And here we go. Next problem. I have 19 and 2 tenths. That's the first thing that I see. So the first thing I see gets shoved underneath my bed when I'm cleaning my room. That becomes my dividend. It's inside the box. And the divisor is at the door. So that's my 4. It's at the door, right? Okay. So just so we can kind of remember, I'm going to multiply and then I'm going to subtract. I'm going to bring 1 down and then I repeat the process all over again. Okay. So going over here, I'm asking myself, I got to multiply first, right? So what times 4 will get me close to 1 without going over? Well, I know the only thing that would work right there is a 0. And I'm just going to skip that part because I don't need a 0 in front of my number, okay? Instead, I'm going to slide on over, yeah, and say what times 4 gets me close to 19 without going over. And I know 4 times 5 will get me 20, but that makes me go over. So I have to stick with 4 times 4. And notice my 4 is up above the 9 because I slid over and I'm trying to go into 19, okay? Don't put it over the 1 because then when I raise my decimal point to the roof, I would be off a place value. So you have to be really careful when you slide over here. Your answer also needs to slide over above it, okay? So now I've multiplying, right? 4 times 4, and that's going to get me 16. And I am ready to subtract, which gives me 3 left over, correct? And then when I'm done subtracting, my B is going to represent bringing 1 down. So I can bring down my 2, correct? And now I'm thinking of what times 4 is going to get me closest to 32 without going over. And I am going to be able to actually solve this one quickly, right? So I'm going to put 8 times 4, right? That's my multiplication because I'm repeating the process. So 8 times 4 is 32. Right? And so whenever I'm subtracting, now I am left with nothing left over. So my beautiful answer right here is ready to go, and that is a 4 and 8 tenths, 4.8. Cool. Ready to move on. Here we go. I think I'm going to, this is a little bit different. Good. Okay. So if I'm looking at this, the first number I see is my dividend. It goes in the box, right? The first thing I see always goes underneath my bed. I'm going to shove it underneath there. Okay. And then my divisor is at the door. Correct. So this is my divisor sitting out here, right? Your rule of thumb is always that this divisor needs to be a whole number every single time. And it's definitely not a whole number. It has a decimal point right there. Okay. So your first thing is identify that it's a decimal, turn it into a whole number. And you do that by hopping your decimal to the right. How many hops to the right does it take for this to turn into the whole number 3? Technically, if you remember, every whole number has an invisible decimal point sitting to the right, okay? So if I'm going to turn this into the whole number 3, that means I am going to move my decimal once to the right, and then it'll sit right there. So when you're moving it, you're literally getting rid of the old location, okay? So it's no longer sitting there anymore. It is now sitting in its new location, yep. And whatever you do to your divisor, you have to do to your dividend. You have to be fair. So if I moved it once, I also have to move this guy once. Okay. So when you move that one, again, the old one goes away. That one doesn't exist anymore. You've moved it, right? And then as soon as you move it, you're going to bring it straight up into your answer, right here into your quotient. okay? So again, just to repeat, whatever you do to your divisor to move it, if you move it once, then you have to move it once here. If I moved this twice, then I would have to move this twice. You have to be fair, okay? So now that I'm all ready to go, I am going to, I'm just going to redraw this so it's not like as confusing, but now that I've moved my, I just messed it up again. Here we go. So now that I've moved my decimal place over 1 and I have turned my divisor into the whole number 3 because I moved my decimal point, I am ready to solve it just like I did with the other ones, right? So I'm asking myself how I can multiply, subtract, bring down, and then repeat my process, right? So I'm going to multiply what times 3 will get me close to 9 without going over. And I know I can do 3 times 3. 3 times 3 is 9, correct? So when I go to subtract, I have nothing left over, right? So that gives me 0, and I'm ready to bring 1 down. It's bring 1 down. I'm not going to bring down the 7 and the 8. I'm just bringing the next one down. So my 7 comes down, and I start the whole process all over again. I repeat it, right? So I'm going to change colors here again, and I'm ready to multiply. What times 3 gets me close to 7? And I know if I do 3 times 2, I will get 6, right? So now I'm ready to subtract, and I get 1 left over, right? When you're done subtracting, you are ready to bring 1 down. So I'm bringing down my 8. And now I am ready to repeat the whole process again. So I'm moving back up to my multiplication and saying, if I go through and I multiply these out, what times 3 will get me close to 18 without going over? And I know that I can, I can multiply 3 times 6. Okay. And that's going to get me 18. And so when I'm on to my next step after multiplying, when I'm on my next step of subtracting, I am finished, right? I left over with a 0. So I know 32 and 6/10 is my overall answer. 32, boop, boop, and 6/10, correct? I'm going to go through and just check and see if there's anything that's a little bit weirder about these, and I don't really see any, so I think I'm probably going to stop there. These are more word problems, so let's jump into these, okay? A total, there's an important word. A total for a restaurant bill is $82.50, right? If the bill is split among 5 friends equally, okay, well, I know when I'm splitting equally, that means I'm going to divide it up equally, right? How much will each person pay? So I'm going to take my total, what I'm starting with, and I'm putting that in my box. That's my dividend, right? So $82.50. And I'm chopping that up. I'm splitting that bill equally amongst 5 friends. So I'm dividing it by 5. Okay. And then I'm going through the entire process all over again. And this is just like any of the other ones. It's just now my answer is going to represent money, right? So 5 times what will get me close to, I'm going to write the steps over here. So we're going to multiply and then subtract, bring 1 down, and then repeat, right? So 5 times 1 is the closest I can get to 8 without going over, right? So I'm going to subtract, and I have 3 left over. I'm going to write smaller. So I did multiplying, I did subtracting, and now I'm ready to bring 1 down. So I always draw the arrow. It helps me keep track of what I've done because things can get kind of messy. You don't have to, but it does definitely help keep things organized. So that's what I would recommend. And now I'm ready to repeat. So I am asking myself now a multiplication problem, right? What times 5 gets me close to 32 without going over? And I know if I do 6 times 5, I end up with 30. So that's my multiplying. I'm ready to subtract now. When I subtract, I have 2 left over, right? And now I'm ready to bring 1 down. So I'm going to bring down my 5. This especially helps my little arrows because I started out with huge numbers and now I have to write smaller because I'm running out of room. So it just kind of keeps it all intact. So I brought one down and now I'm ready to repeat my process all over again. So I'm choosing another color just to emphasize that for you guys. Okay. So what times 5? It's my multiplication step. What times 5 will get me 25? And I know 5 times 5 will get me 25, right? So when I'm done, I'm going to subtract and I get 0. And this is the tricky part. Some kids are like, oh, I got a 0, I'm done. And then they just end it. You can't. You still have stuff up here. So you still want to keep going. Okay. So just because you have a 0 here doesn't mean you're not ready to bring something down. So I am going to follow through with the bring down step. I'm going to bring down my next 0. Just to like emphasize that, right? And I have to repeat because it's just hanging there, right? So what times 5 will get me closest to 0 without going over, and that is of course going to be 0, right? 0 times 5 will get me 0, and I can subtract and be done with the full process there. Now keep in mind, I went through on this one, I completely forgot. Usually I do it right at the beginning, but if you have your decimal point, make sure that you bring it straight up. And this is why it's so important to keep your columns straight, because you may accidentally have your numbers written a little too big or a little too small up here, and then your decimal is in the wrong spot, and that will totally change your answer. Okay. So overall, I have 16.50, which, if you think about it, this is a money problem. So that means my answer is $16.50. Okay. Don't leave off that 0 because we're talking about money, and you usually don't say $16.05 and write it like that, correct? This is 50. If you have a 5 right next to your decimal, it's going to represent 50 cents. Okay, so just keep that in mind. Let's look at the last one here. Okay, suppose 2 4/10 liters of water came out of a faucet each minute. So that's kind of the rate that the water is flowing out of your faucet, right? 2 4/10 of a liter. So think of a 2-liter of soda, right? About a 2-liter of soda and then close to a half of a one, just to wrap your brain around that. Okay, so that's coming out each minute. For how many minutes was the faucet on if 51 6/10 liters came out altogether? Okay, so I am looking at this as my total, right? And this is how much will come out each minute. And I want to know how many minutes it's been on, right? So I'm going to take my total and I'm going to chop that up evenly by how many liters come out per minute. Okay, so that's how I know. I don't get to just look at this and say, oh, this is my big number, so it's going to go in here. Because now that we're in 6th grade, this is not always the larger number. Sometimes it is the smaller number. So don't just look at 2 numbers and assume that the big number is always going to go on the outside, okay? Or on the inside, I mean. So here we go. We're going to walk through this one more time. We do have a decimal point here, and we want it to be a whole number, right? So I'm going to hop it once to the right. And if you do it there in your divisor, you have to do it once here at your dividend. So now I have the whole number 24 on the outside, right, as my divisor. And this number is now 516. Okay, I got rid of my decimal points altogether. Technically, it's sitting right there. So if I want to bring it straight up, I can in case I'm going to need it later in my answer. It's there. Okay, so let's go through and I am going to start that process all over again so I have more room to write. So 516 divided by 24, because that's what it looked like after I moved my decimal points, right? And it is sitting right here just in case I need it. Yeah. So we are going to do the multiply, subtract, bring down 1, and then repeat as necessary, right? So this one's a little weird. It's a little different, but it's not as hard because you guys literally get a fact chart that goes up to 25. So this guy will even be on there, right? So I'm just looking to see 24 times what will get me close to 5. It's not going to happen, right? But if I slide over to 51, that will definitely happen, right? So I know that if I take 24 and I multiply it by 2, that's going to get me 48. So I'm going to make sure I don't put it above the 5 because 24 didn't go into 5. 24 went into 51. So I'm going to slide over here to put my 2. Okay, so that way my columns are lining up and they're ready to go where it's supposed to go in relation to my decimal. So now I've multiplied, right? 2 times 24 is going to get me 48, right? 48. And I'm ready to subtract. Okay, so when I subtract, I end up with 3. I didn't do that. I end up at 3. I don't know why. Sorry. So after I subtract and I get 3, I am ready to do a look-see over at my checklist over here. I'm ready to bring down, correct? So I'm going to bring one more down, just 6. That's my next one to bring down. And repeat my whole process. I'm going to slide over to a different color real quick and just say what times 24 will get me close to 36. And I know I could only use 1. That's the only thing that's going to happen, right? So I'm going to say 1. My trackpad's acting really weird, sorry. 1 times 24 is 24, right? And when I subtract that out, I end up with 12. Okay, this one's a good one to learn from as well. So again, I have leftovers. I cannot put or 12, right? We're not doing that anymore because that doesn't really mean anything. So instead, because we have a decimal point and it's already sitting here, I get to just add a 0. So that way I can go through and I can bring 1 down. Okay, and that'll let me continue the process with the number 120. Right? So I brought that down and now I'm ready to repeat. So I'm going to use a different color and I'm going to go back up to the top and say, I'm ready for multiplying. What times 24 will get me close to 120 without going over? And I can actually use 5 times 24 and that gets me exactly 120. Okay. And again, you have a fact chart that goes up to 25. So none of this had to be like hand calculated out to the side. I can use my fact chart and quickly plop these out if I don't know them off the top of my head. Okay, so quick and easy math right there to just reference your chart and make sure that you don't have any little like oopsie calculation errors. So now I'm finished, right? I have 21 and 5/10 or 21 and a half liters. 21 and a half minutes is how long the faucet would have to be on in order for that much water to come out. Very cool. Okay. Ta-da. And that is it.